So in our experiments, we have a big issue because we use ethanol, and ethanol is an alcohol that evaporates pretty easily for heat. So to solve this problem, well, originally we used petri dishes like this, just regular old petri dishes. And the issue with our experiment is we need oxygen to get into the anthraquinone so that we can make our hydrogen peroxide. Now, we believe that with a petri dish like this, there's not enough oxygen coming in. So we decided to fix that. We have come up with 3 different contraptions. This one is a modified petri dish that has little cuts in the side. So when the top is on, you can still have the air come in through these little cuts. Our next option is just a nice big slit in the side. If you can see, you can have an opening where the oxygen can come in. And lastly, we drilled a giant hole in the top. We're working on different gauges of the hole. And lastly, we have this flask. It has a modified opening at the end. So we are hoping that if we have our solution in here, we can have the oxygen come through here, and that would limit the evaporation.
Okay, so to drill holes in the tops of our petri dishes, we're using different gauges, different diameters for the drill bits. And we've got this smaller one. We're using this power tool to drill the holes in this with a wood backing so that we can try to get it crack free. So far, we're not successful with that, but we're working on it.
So along with our creative top and petri dish solution, we have contacted a number of different companies on oxygen permeable membranes. These membranes will hopefully only let oxygen in, but keep our evaporation low.
Go. So we're going to begin testing our different variables in our experiment, one by one. One of the first problems we noticed is that our concentration of anthraquinone, our catalyst, is rather low in our samples. In Kenya, we're hoping to have a high concentration of our catalyst. Therefore, we're hoping we'll create more hydrogen peroxide from that. So, we're making different solutions of our catalyst. We're going to make a 1 millimolar, 5 millimolar, 10 millimolar, and 20 millimolar, and test each one in the sunlight to see which one produces more hydrogen peroxide in the end. In addition, we're going to test lower concentrations of our alcohol. In Kenya, it's going to be difficult for the locals to grab 100% pure ethanol from just nowhere in particular. They're probably going to have types of alcohol such as rye beer and others that have low concentrations like 2% or 5% ethanol in them. So we're going to begin testing with 2% or 5% ethanol and seeing how much hydrogen peroxide we can produce from there. Our goal is that eventually we'll have a system worked out just perfectly so that the lowest amount of ethanol can create the highest amount of hydrogen peroxide in the future.